Nvidia has just redefined the future of artificial intelligence. In a jaw-dropping reveal that sent shockwaves across the tech industry, Nvidia unveiled its newest AI chip. And it's not just an upgrade, it's a revolution. We're talking about a performance leap that seems almost unreal, up to 1,000 times faster than its predecessors. That's not a typo. That's the kind of leap we usually expect over decades, not product cycles. But here we are. Welcome to the next era of computing. In a world where milliseconds matter and data is growing exponentially, this AI chip could be the key to unlocking unimaginable power in machine learning, robotics, scientific research, and even gaming. But what makes this chip so special? How did Nvidia achieve this leap? And what does this mean for the future of AI, business, and everyday users like you? Here's the twist that will blow your mind. Nvidia isn't just making chips faster. They're redefining how computers think. And by the end of this video, you'll understand how this chip might just power everything from self-driving cars to next-gen medical diagnostics, and why missing out on this innovation might mean falling behind in the tech race. To truly understand the magnitude of this release, we need to rewind for a moment. Nvidia has long been a titan in the graphics processing world. From powering your favorite games to driving AI and data centers, they've set the gold standard. But this chip, codenamed Blackwell, is not just another iteration of a GPU. It's a new breed entirely. At its core, Blackwell represents a fundamental shift. Nvidia designed this chip from the ground up specifically for AI workloads, unlike previous generations that adapted gaming chips for AI use. This architecture is optimized to handle trillions of operations per second. Operations that power large language models, image recognition, autonomous navigation, and scientific simulations. So how did Nvidia manage to squeeze 1,000 times more speed into a silicon wafer? First, let's talk architecture. Blackwell uses an advanced multi-die design, enabling unprecedented scalability. That means more cores, more memory bandwidth, and massively reduced latency. But the real magic is in how those dies communicate. Nvidia has developed ultra-fast interconnects that allow data to move between components at blazing speeds, solving one of AI's biggest bottlenecks: the time it takes to move data. Second, this chip is built using bleeding-edge 3-nanometer process technology. This allows Nvidia to pack more transistors into a smaller space, dramatically increasing efficiency while keeping power consumption under control. That's important because AI models are becoming more complex and energy demands are skyrocketing. Blackwell solves that. But Nvidia didn't stop there. This chip introduces the second generation of Nvidia's transformer engine, tailor-made for large-scale AI models like the one you're interacting with right now. It dynamically adjusts precision levels during training and inference, striking the perfect balance between performance and accuracy. That means faster training times for massive models without sacrificing output quality. Now let's talk numbers. When compared to the previous Hopper generation chips, Blackwell delivers up to 4 times better training performance and up to 25 times the energy efficiency. And when used at scale, across hundreds or thousands of GPUs, the improvements compound, leading to performance gains that can reach up to 1,000 times in certain AI workloads. For enterprise, research, and national labs, this is monumental. You're probably wondering what this means in real-world terms. Let's break it down. Imagine a large language model that currently takes weeks to train. With Blackwell, that timeline shrinks to mere days. In mission-critical scenarios like disease modeling, financial forecasting, or real-time logistics optimization, this kind of speed isn't just convenient, it's transformative. In the automotive world, Blackwell could accelerate the development and deployment of autonomous vehicles. Self-driving algorithms rely on petabytes of data to simulate driving environments. What once took months to train can now be done in a fraction of the time. That means faster innovation and safer roads. In healthcare, AI models trained on vast datasets of genetic information and medical imaging can identify patterns that were previously invisible. With Blackwell, this process becomes faster and more precise, unlocking new frontiers in personalized medicine and early disease detection. In gaming and creative industries, Blackwell's compute power allows for real-time rendering of complex scenes, AI-generated assets, and hyper-realistic environments. This goes beyond visuals. It transforms how we interact with digital worlds. And if you think this is just for the big players, think again. Nvidia is also working with partners to bring Blackwell into the cloud. That means startups, developers, and small businesses will have access to this kind of AI firepower on demand, leveling the playing field like never before. But this breakthrough isn't just about hardware. Nvidia has built a full-stack AI platform around Blackwell, including its CUDA software ecosystem, optimized libraries, and powerful development tools like TensorRT and Triton Inference Server. This means developers can immediately begin building and scaling applications without reinventing the wheel. So what does the future look like with a 1000x faster AI chip? Picture this: AI assistants that understand your intentions with almost no delay. Real-time translation that's context-aware and culturally nuanced. Robots that can adapt and learn in dynamic environments. Financial systems that can prevent fraud before it happens. Search engines that don't just find answers, but understand what you actually want. And perhaps most importantly, a massive leap in scientific discovery. From climate modeling to quantum simulations, Blackwell enables researchers to explore questions we previously lacked the power to even ask. Now, let's be real. There are still challenges. Integrating this kind of power at scale requires robust infrastructure, cooling, and software optimization. It's not a plug-and-play upgrade. But Nvidia isn't just shipping chips. They're partnering with cloud giants like Microsoft, Google, and AWS to ensure that Blackwell's power is accessible globally. They've also introduced DGX SuperPODs, modular AI data centers powered by Blackwell, capable of supporting trillion-parameter models. These systems aren't just fast. They're designed for sustainability, using AI to optimize power usage and cooling. That means more power with a lower environmental footprint. We are at the tipping point of what many call the AI industrial revolution, and Nvidia's Blackwell chip is the engine. To put this into perspective, the last time we saw a 1000x jump in computing speed, it took nearly 20 years. Blackwell delivers it in a single architectural leap. If you're in tech, finance, medicine, education, logistics, or any field that touches data, and let's be honest, that's all of them, this is a moment you need to understand. Because the rules of the game are changing. And this is where it gets personal. The AI experiences you'll see in the next 12 months will feel like science fiction compared to what we had just a year ago. We're going to see AI that doesn't just assist, but collaborates. AI that designs, diagnoses, creates, teaches, and yes, learns. In real time, at scale. All thanks to a tiny piece of silicon that's changing everything. If this blew your mind, imagine what's coming next. Nvidia is already talking about pushing the limits of Blackwell with next-gen systems. And with competition heating up from AMD, Intel, and even custom AI chips from cloud providers, the pace of innovation is only accelerating. But right now, Blackwell stands as the most powerful AI chip ever built. And it's not a prototype. It's real. It's shipping, and it's rewriting the future as we speak. If you've made it this far, you're clearly someone who understands the importance of staying ahead of the curve. So here's your moment. Smash that subscribe button right now, because we're diving deep into the bleeding edge of AI, chips, and the tech that's changing our world. Thanks for watching, and stay tuned. The future is accelerating faster than ever.